Let's now take up the next concept in this chapter, and that is the concept of a segment of a circle, right? Now we've already looked at what the sector of a circle is. Now let's look at another component, another part of a circle which we can have, and that's a segment. So if, for example, we have a circle, and if I take any 2 points on its radius, on its circumference, so AB, so AB is an arc, right? AB is an arc. And if you join AB, then AB line segment, it becomes a chord of the circle. Because a chord of the circle is a line segment which joins any 2 points on the circle, right? That's the chord of a circle. Now, you see that there is some region created here, right? Can you see this part? This is the region which is created, this region here, right? This region which is created or which is enclosed by a chord and a corresponding arc of a circle is called the segment of the circle. It's called a segment of the circle. So this is a segment of the circle. Again, there are two kinds of segments. There is the minor segment and there is the major segment. This small area segment is the minor segment, and this segment of a larger area, this segment here, this is your major segment of a larger area. Major segment, right? So these are the two segments of the circle, and basically now let's define a segment properly. So a segment is defined as the region enclosed by an arc and sorry, not by an arc, let's write it like this, by a chord and the corresponding arc of a circle, and the corresponding arc of a circle, right? So that's your segment. So there are again two kinds of segments, major segment, minor segment. I think you can figure it out, right? So that's your segment concept. Now, how do we find the area of a segment? Now that's a good question. For example, we have a circle here, and we take any 2 points on the segment on the circumference, so AB, and we draw the chord joining AB, and you know that there will be a center of the circle. Suppose this is the center of the circle. Now, if I join A to O and O to B, A to O and O to B, right? You can say that there will be a sector forming, right? Can you see this? This is a sector, right? This is a sector. Now a sector is being formed. Now there is a sector and there is also a triangle, right? There is also a triangle. Can you see that? There is also a triangle. So to find the area of this segment here, we basically need to find the area of the sector and then subtract this triangle AOB area. You will be left with this area, right? You getting my point? We take the area of the sector and from that we subtract the area of this triangle AOB, and then we get the area of the segment. Right? So to formulate this in the form of an equation, the area of the segment, here we're talking about the minor segment which I've shaded, right? So area of the segment is equal to area of sector minus area of corresponding triangle. Area of corresponding triangle. This is your area of the segment, right? Now there'll be an angle of the segment. We all know that. That's theta. So suppose this is the angle of the segment, theta. So can we formulate an equation? No, we cannot. Why? Because this triangle you cannot just find the area of the triangle, right? That's the problem. Now this is going to be R and this is going to be R, right? So that's your area of the triangle you can find, and the area of the sector. Subtract the area of the triangle from the area of the sector, and then you'll get the area of the segment, right? Now consider different cases of this theta, right? There are some special cases of this theta according to which we can have a formula if there is a certain condition for theta. So let's find that. Let's take some cases, right? So this is the case and this is my formula for that case, right? So I'm going to formulate this in the form of a table. Suppose theta is equal to 60 degrees, right? Now, if theta is 60 degrees, right? If suppose theta is 60 degrees, you know that this angle and this angle have to be equal, right? Because it's an isosceles triangle. AOB is an isosceles triangle, so this two have to be equal. If this is 60, so we can say 60 plus, suppose this is x and this is x, 2x will be 180, right? So 2x will be 120, hence x will be 60. So you can see that all the angles of that triangle become 60. Now, if all angles of the triangle are 60, we can say that the triangle is equilateral. It is equilateral. So if theta equal to 60, then directly area of triangle AOB becomes root 3 by 4 r square, right? Because you know that the formula of the area of an equilateral triangle is root 3 by 4 into side square. So here the side will be radius, so r square. And accordingly, you can subtract this from the area of the sector and find the area of the segment, right? So that's one case. If theta is 60, that triangle becomes equilateral, and then area of the triangle becomes directly with the formula root 3 by 4 r square. Subtract that from the area of the sector and you'll find your area of the segment, right? Next case, this was case 1. Case 2 is if theta is 90. Well, if theta is 90, it's a right angle triangle, right? And you can directly use the formula half base height. So area of triangle AOB becomes half into the base will be this, right? OB. So it will be R. Height will be AO. Since this is 90, this is the perpendicular on this. So AO again R. So half R square. Right? So that will be your area of the triangle AOB in case your theta becomes 90 degrees, right? So I hope that's absolutely clear, right? So I've given you some certain cases that can help you in certain cases, right? But overall, you should be using this fundamental to solve problems relating to area of the segment, right? So I hope that's absolutely clear. This is as per your textbook, whatever is there. Now, let's leave the textbook for now. For about 2 minutes, leave aside NCERT, right? I'm going to tell you one formula which you can use directly for your competitive examinations or for checking your answer. Do not use this formula in your actual exam calculations. Please mind it. You will lose marks because it depends on your examiner. Sometimes they don't give you marks for this because it's a direct formula. So don't use it, please, please, okay? Just use this when you are writing a competitive exam or something like that. Now, you know that it is an isosceles triangle, right? Two sides are equal. You know it's an isosceles triangle. Triangle AOB is isosceles. So you can use this formula to find the area of any isosceles triangle if the equal sides are given and the angle between the equal sides are given. So here you can see triangle AOB where O and OB are known because both are radii and they are both the equal sides, and the angle between them, that is theta, is known, right? So in this case where the equal sides are given and the angle between them is known, that time area of an isosceles triangle in this case only, if the angle between them is also given, becomes half r, not r square exactly, let's say a square sine theta. You can only use this for your competitives. Don't use it in your NCERT, please, okay? So half a square sine theta, where a is the equal side of the triangle, right? For example, here it's r, right? Both are equal sides. So that equal side length is given to you and the angle between them here, which is theta, is given to you. Then you can use that formula, right? So let me draw a triangle for this so you can understand it better. If you have a triangle which is isosceles in which these two are equal, it's some a, it's some a. Suppose this is some triangle ABC, and this angle is given to you as theta, angle between them. So then in this case, you can use this formula and find the area of this triangle. Right? So you can use it here too, but not in your NCERT, because sometimes board examiners will not give you answers. They'll not give you marks for it because it's not there in your course. So please don't use it just in case. For now, you can just use it for your competitive examinations. Right? So I hope that's absolutely clear. Right? So that's your concept of segment and the area of the segment of a circle. I hope that's absolutely clear to you. Any kind of doubt is welcome in the comment section below. And with this, we are done with all the lectures on the concepts and areas related to circles. Right? Sometimes you'll get combinations with plane figures. Right? In that, you're just using these two concepts. Right? You're just using sector, segment, and actual area of a circle. So you get combinations. That's your last part. But I'm not going to make videos on that because that's pretty obvious. You get direct questions. Right? So I hope that's absolutely clear to all of you. With this, I conclude this chapter in terms of the lectures on the concepts. I hope you're absolutely clear with it. Any kind of doubt are welcome in the comment section below. Right? So please like and subscribe, share this video with your friends, and any kinds of doubt welcome in the comment section below. Best of luck for your examinations. Goodbye, stay healthy, stay smart, and do keep studying. Bye-bye.